Hi everyone, for this question they ask us to find the critical numbers for the curve y equals to 3x power 4 minus 4x power 3, hence determine the point of inflection. So critical numbers here is referred to your x. What is your x here? When it be critical number, it will be occur when your dy dx equals to 0, which is your gradient of the tangent equals to 0. So from our curve here, y equals to 3x to the power of 4 minus 4x to the power of 3. Firstly, you find out what is your gradient of the tangent dy dx. Power move to the front, power minus 1. To get it critical, we need to let this dy dx equals to 0. We can see our equation here has similar multiplier here. We simplify. We divide by 12. X cubed minus x squared equals to 0. Then we can do factorize. Take out x squared. You are left a x minus 1. So from here, your x will be equal to 0 and x equals to 1. So this is your critical number. Alright, so when we move on, they say hence. Determine the point of the inflection. So the point of inflection here, we need to do the test. So our critical number haven't do the test. We use second derivative test, so that we can see it concave outward and concave downward. If we have changes of the concavity on the point, so that point will be our inflection point. If you don't have any changes, it will not be inflection point. So from there, we need to find out our second derivative. Second derivative, when we finding d2y dx squared, differentiate one more time. Power move to the front, power minus 1. So from second derivative, we might consider it will be have a inflection. It may be when d2y dx squared equals to 0. So we try to find out it first. 36x squared minus 24x equals to 0. We simplify here, we can divide by 12. 3x squared minus 2x equals to 0. We factorize out x, and this get 3 minus 2. So our point x equals to 0 and x equals to 2 over 3, there might be a inflection point also. So why we need this? So because when we have these two critical number, we will we need to observe what happened before 0 and what happened after 0, what happened before 1 and what happened after 1 to see its concavity. But then, don't forget that when we have d2y dx squared also, we might create an inflection point here. So you can see we have a new figure on x equals to 2 over 3. Therefore, when we want to test our critical number x here and value x here, we need to consider your value, which is these three values on different interval. When we have three values, our interval will be having four interval. Three value of x, rearrange from smallest to the bigger. So x equals to 0, x equals to 1, this is the middle value. The value at the center, then x equals to 2 over 3 first, and x equals to 1 lastly. Therefore, our interval will be x less than 0. Before 0, we want to see after 0, it will be x in between 0 and 2 over 3. Then after 2 over 3, before 1, x in between 2 over 3 and 1. After 1 will be x more than 1. Then we will randomly pick a test value within the interval to see the second derivative sign, so that we can come up with the conclusion on the concavity. So less than 0, we can take a -1. In between this one, we make it decimal, it will be 0.67. So in between that, I take 0.3. This one, I take 0.8. More than 1, and we can take value of 2. So when we calculate for -1, we can notice that our d2y squared will get positive. So this is concave upward. Repeat for another test value 0.3. This is negative. So this is concave downward. Then calculate for 0.8. So this is positive, concave upward. Then lastly, calculate for value 2. It is also positive, concave upward. So when we have changes in concavity, the value that you want to test here, it will be inflection point. So here we can create an inflection point when x equals to 0 and also when x equals to 2/3. Since you need a point, which means that we need a coordinate here. Now we proceed to find out the coordinate. When x equals to 0, y will be substitute back its original function here, 0 minus 0, it will be 0. So you have a 0, 0, another one. Another point that we found that it have changes concavity before and after is x equals to 2/3. So the y coordinate here will be 3 times 2/3 power 4, then minus 4 times 2/3 power 3. Okay, so wait a minute. We need to press calculator and find out what is the coordinate of y. We have -16/27. So therefore, 0, 0, and another one point is here 2, 3, -16/27. They are inflection point. Alright, so that's all for this. Thank you for watching.